Here's my circuit for project 1. It consists of 4 BJTs, one of which is an NPN. The other 3 are PNP transistors, which each have their own filters, a low pass filter, high pass, and a band pass filter between them. It's designed that the BJTs are always in active mode, and the gain changes depending on the frequency input. So let's look at the DC voltage values, and considering there's 4 transistors here, I'm just going to look at the one connected to the high pass filter for simplicity. So the base, we're getting a voltage reading of about 8.7 volts. At the emitter, here we go, just slightly higher. And then at the collector, we're getting about 600 millivolts-ish. Remember, this is a PNP transistor, so for it to be active, the base voltage at 8.7 volts needs to be higher than the collector voltage, which is at about 0.6 volts, which it is. Earlier, I tried to measure the current through this transistor and got values that didn't make much sense. The current at the base was about 0.2 milliamps, and the current through the collector was about 1 milliamp. My suspicion is the collector branch, which includes these LEDs, has too high of a resistance, and it's limiting that current. So I have a secondary simple circuit here with another one of these PNP transistors. It's a 2N2907. We can measure the currents on this one and calculate beta. So let's look at the current through the base. About 320-ish microamps. 0.315. And the current through the collector over 80 milliamps and climbing. It usually keeps climbing as the temperature in the transistor increases, and it does get pretty hot with this much current. So let's call it about 90 milliamps. Which gives a beta of around 280, 285. And that value meets the spec sheet for these transistors. Now let's measure some gain values for this transistor. It's the one connected to the high pass filter and these red LEDs. Currently, the circuit's operating around 392 Hertz, or middle G, and that's where I tried to center these filters. So the high pass filter is currently out of operating range. So we can see the input here currently, which is just under 200 millivolts at 392 Hertz. Let's look at the output values. go. So currently getting a peak-to-peak output on that transistor of around 1.6, maybe 1.5 volts. And the peak-to-peak input was 200 millivolts. So that's a current gain of around 8. So if I increase the frequency here up into the operating range, we'll go about 4,000 hertz. Notice the red LEDs brighten up. So we got 4,000 hertz, 200 milliamp input. There's our output voltages, looking about 4.6, 4.7, maybe volts peak to peak. So that's a gain of around 23. So we're well inside the operating frequency for that part of the circuit. So now I'd like to demonstrate what this circuit is actually designed to do, which is take in audio signals and split it up with the 3 filters. So I've removed the my DAC input and replaced it with this audio input. So if I provide a tone, such as middle G or 392 hertz, which hopefully you can hear over this little speaker, and you'll notice the LEDs light up. My goal was try to center it around middle G so that the bandpass filter with the yellow LEDs is fully on and the low pass and high pass filter are just barely off. So if I provide a lower tone, such as middle C or 262 hertz, notice the high pass filter red LEDs are now fully off and we're getting more blue or low pass. A lower tone still, and these are going to be difficult to hear over my speaker. This is 196 hertz or G3. And then 131 hertz or C3. At this point, the low pass filter is fully on. You'll notice that the yellow or bandpass filter in the middle is still on. This isn't what I would like, but unless I redesign the circuit using, second order filters, the decay isn't steep enough outside of the operating range. So there's quite a bit of overlap between these filters. So let's try some higher tones. It's middle G again. And 523 hertz or C5. Notice the high pass red LEDs are much more active. And blue is almost off. And 784 hertz or G5. At this point we've got the red LEDs fully active, blue LEDs are off. So while those pure tones are a good demonstration of how the 3 filters work, The circuit really shines when music is applied to the input.